Hi guys, in this video we're going to discuss about network scanning concepts. As already discussed, footprinting is the first phase of hacking in which the attacker gains primary information about a potential target. He or she then uses this information in the scanning phase to gather more details about the target. So let's say if I have a computer, right, or maybe a server connected, right, connected to a switch, right, and then maybe there is another computer connected to that switch, right, and let's say there is an attacker who wants to actually um, do the network scanning, right? But the thing is that, first of all, before even getting into the network scanning, he has to know what IP addresses or maybe what kind of operating systems are there running over there. So that's how you actually gather it from the footprinting or reconnaissance attack, right? So we are done with the footprinting and reconnaissance attack. So we know now that three systems are enabled, are connected to the switch, and then we have got three IP addresses collected from reconnaissance attack or footprinting, right? Now, overview of networking scanning is like network scanning refers to a set of procedures used for identifying host, ports, and services in a network. So maybe there are three computers, right? So first of all, when you're going to scan, it will actually let you know that there are three systems turned on, right, connected to the network, and maybe that would be the identifying of host, right? And when you know that there are three systems, now you're going to find that how what ports are enabled on that systems. Let's say what ports means. Let's say is it port number 80 HTTP? Is it port number 443 HTTPS? Is it port number 2021 FTP? Is it port number 25 SMTP? So those are the port numbers, right? And then you also are going to actually know the services running at the background, right? So that means what kind of services related to that port numbers that are running services, right? HTTP, HTTPS, and all this kind of stuff. So that's how you actually gain the information from network scanning, right? And network scanning is one of the components of intelligence gathering, which can be used by an attacker to create a profile of the target organization. So if I'm going to talk about objectives of network scanning, it would be to discover live host, right? So it could be to discover live host, right? And then the host that contains the IP address, right? And the open ports, right? So the open ports means the ports that are enabled, that are turned on, right? Open ports. And then another one would be second objective of network scanning would be to discover operating systems. So what kind of operating system is running on that specific system and the system architecture, right? And then third objective of network scanning would be to discover services running on, right? So services running on the host. So what kind of services? Is it actually SMTP? Is it actually SSH? Is it actually Telnet? Is it actually HTTPS? Something like that. So those are the services. Now, another thing would be objectives of network scanning. So to discover vulnerabilities, right, in live host systems. So vulnerabilities. Now, what is vulnerabilities? Vulnerabilities is something like the system weakness, right? You find the weak point of that system to get into that system or to just penetrate into that system or network. So that these four information are the objectives of network scanning. So the purpose of scanning is to discover exploitable communication channels, probe as many listeners as possible, and track the ones that are responsive or useful to an attacker's particular needs. So in the scanning phase, right, of an attack if I'm scanning in the network, right? So those probes are going to go to each of the systems that are connected to that network, right? And then I'm going to get the information, right, about the target system to determine the presence of any configuration lapses. So the attacker then uses the information obtained to develop attack strategy just by collecting these informations, right? So yeah, that's how we actually gain information by just sending a type of probe, right? So there are a lot types of probes we will discuss after this, right? So let's discuss about the network, um, or the types of scanning that we're going to do over here. So firstly, we are going to discuss about port scanning. So port scanning is the process of checking the services running on the target computer by sending a sequence of messages in an attempt to break in. So if I'm going to actually draw a computer over here, and let's say that's the server on the other side, and those are connected, right? So this is the attacker, and this is a normal PC, right, or a server. So right, when we're going to scan the port, right? So port scanning involves connecting to or probing TCP, right? Or and UDP ports, right? So UDP ports of the target system to determine whether the services are running or are in a listening state. So the listening state provides the information about the operating system and the application running in use. So maybe some kind of application is running, and then operating system, what kind of operating system is running. Either it could be Linux, either it could be Windows, either it could be Windows clients or Windows Server. So when you're going to hit to that system with a probe, so the system actually replies to that probe, right? By that reply probe, this system, the attacker system, will know that what kind of operating system is there, what kind of application is running on that system, right? So sometimes active services, such as, let's say, FTP, such as SMTP services, such as HTTP running services, right? That are listening may allow unauthorized users to misconfigure systems or to run software with vulnerabilities. So maybe if you're running the default insecure protocols, right? So insecure services, right? So maybe if you're running these insecure services, it may allow unauthorized users to misconfigure the system or to run software with kind of some kind of weakness, right? So if you are running these insecure services, that means those are vulnerabilities. Why? Those are weakness of the system. So anyone who knows about those weakness of the system, that means they are going to be allowed to the system, and then they can misconfigure, or they can actually turn down that services that is running over there, right? So yeah, that could be done over here in the port scanning. Now, second type of scanning is known as network scanning. So in this type of scan, maybe um, it will actually list the active host and IP addresses in the network, right? So you have got that attacker machine connected to the centralized switch, and all of the machines are also connected to that switch, right? So network scanning is a procedure to identify, right? To identify active host on a network, right? Either to attack them or assess the security of the network. So this is how it is actually different than the port scanning, because port scanning is you are actually scanning a specific a computer, and then you wanted to know what kind of operating system is running, what kind of applications, what kind of services are running on that specific computer. In network scanning, you wanted to know that how many computers are connected to the network, so that I can know the IP address of the network and how many computers are actually connected or enabled on the network. Thirdly, vulnerability scanning. So it shows the presence of known weaknesses of a system. So maybe, like, let's say there is a server and attacker connected to that server, right? So, yes. So, vulnerability scanning is a method of checking whether the system is exploitable by identifying its weakness, right? A vulnerability scanner consists of a scanning engine and a catalog. The catalog includes a list of common files with known weakness and common exploits. So for a range of servers, right? So a vulnerability scanner may, for example, look for backup files, right? So it may look for backup files, or directory, right? Some kind of directory, which is actually maybe shared or maybe is available in the network. The scanning engine maintains logic for reading the exploit list, transferring the request to web server, and analyzing the request to ensure the safety of the server, right? So these tools generally target vulnerabilities that source the host configuration can fix easily through updated security patches and a clean web document, right? So, for example, let's say a thief, right? A thief who wants to break into the house, right? So that means he looks for access points such as doors, right? Such as doors, or maybe such as some kind of windows. So these are usually the house points of vulnerability, the weakness of the house, right? Maybe the door is not locked, is unlocked. Maybe the window is open. So you can find those are the weaknesses of the house. So you need to make sure that it is actually locked very, let's say, carefully, or maybe it's locked very tightly, so no one can come in, right? So those are the things. When it comes to computer systems and networks, port are the doors of the and windows of a system. So ports. So what could be the port? It could be anything. The port actually ranges from 0 to 65,534, right? So these are the number of ports. So it could be anything. The well-known ports actually ranges from 0 to 1023, right? So within this well-known ports, you will be having such as, let's say, 2021 FTP, right? Both ports. 22 SSH, right? 23 Telnet, right? And 25 SMTP, right? Maybe let's say um 67, 68 DHCP, right? 80 HTTP, and then 110, right? Pop. So those are the things, right? Version 3, 109, pop version 2. So those are the things. So these are the well-known ports. And then these are the default ones that are sometimes are enabled by default in operating systems, right? Yes. So these are the things you need to make sure that the well-known ports are actually also some kind of some kind of maybe, let's say, it could be a weakness of a system if you are using if you are using telnet, right? So telnet, when you are actually hitting to the system, telnet is some kind of let's say the protocol. When you are it's a service, you get the access of that system, remote system, right? Let's say if you want that systems access through CLI mode, either you can use telnet or SSH, but we prefer using SSH over telnet. Why? Because telnet is insecure. When you're logging into the system and you're using telnet, that means the username or password are actually uh, traveled in, let's say it travels in clear text. So if someone is actually sitting in between, right, in the middle, and then actually he sees this, that means he will know that, okay, that's the IP address and this is the password. So he can get into the system easily. So that's one kind of thing that we never use telnet, right? So this is, let's say, this is um, some kind of weakness of the system by default. So on top of that, we use SSH, or either we use 80, right? And then 443. So 80 is HTTP, 443 is HTTPS. We use HTTPS over HTTPY, because even HTTP is insecure a service, right? So even if you're using HTTP, the user name and password are actually being carried in clear text. So in HTTPS, it's going to be actually secured. So this is how we actually make sure that the system is not that vulnerable, but yes, we actually mitigate by using stronger protocols or services other than running the default services, right? Such as telnet, HTTP, those kind of things. We're going to learn about and understand regarding the TCP communication flags. So, the TCP header contains various flags that control the transmission of data across a TCP connection. Six TCP control flags manage the connection between host and give instructions to the system. Four of these flags, such as SYN, ACK, fin, and reset govern the establishment, maintenance, and termination of a connection. The other the other two flags, such as push bit and urgent bit, right? Urgent flag, provide instruction to the system. The size of each flag is 1 bit. As there are 6 flags in the TCP flags section, the size of this section is 6 bits. When a flag value is set to 1, that flag is automatically turned on. Now, before even getting um, in this video, I would like to refer you to go through the videos that you can actually understand the basic and fundamentals of TCP communication. So just go through Trainonic, and then if you have got the access, just click on courses. And after clicking on the courses, you just scroll down. There are a number of courses in English as well as in Hindi. As of now, we don't have available in English. CCNA. Let me check if it's there. Cisco Advanced Switching, Cisco Networking, CCIE, and these are all securities. So I'm going to come back and down here. There you go. The Cisco CCNA 200-301. So if you click on that, Cisco Certified Network Associate Learning, right? So scroll down a little bit, and there you can see describe Ethernet as network access layer of TCP and describe operation of switches, right? So you need to make sure that you understand the TCP IP internet layer and the OSI model. So always make sure that you understand the host communication before even getting into these flags, right? So why I'm telling you, because when I'm actually telling you about the TCP communication flags, I'm actually referring to the transport layer, right? So yeah, you need to understand the transport layer protocols first. If you are dealing with the transport layer protocols, either you are dealing with the TCP protocol or you are dealing with the UDP protocol. So you need to make sure that you are clear with the concepts of TCP and UDP. So for basic understanding of those TCP and UDP, you can actually go through the Cisco Certified Network Associate certification. Either you can actually go and take courses one-to-one or maybe online courses, but you need to make sure that you know the OSI and TCP IP model flow, right? So yeah, before even getting into the um, TCP communication flags that I'm actually making you understand over here. So, okay, so I was talking about the flags, right? So, okay, so we have got 6 flags over here. So one would be the origin bit, the acknowledgement bit, the push bit, the reset bit, the send bit, and the fin bit, right? So yes, if we are talking about these bits, right? So how do we put into it? So these are known as TCP flags, right? So um, it purely depends upon the transport layer, right? So within transport layer, you have got TCP and UDP running on it, right? And then what we are talking about is in the TCP header, right? So the TCP header includes this ranges of TCP flags. So the following are the TCP communication flags. And first of all, let's understand the SYN bit, also known as synchronize. So it notifies the transmission of a new sequence number. This flag generally represents the establishment of a connection, the three-way handshake between two hosts. So how do we actually know how the three-way handshake works? Okay, so let me clarify with the synchronization bit and the acknowledgement bit, right? So let's say I have got 2 computers, right? And these 2 computers are communicating with one another. If this is the sender and the other one is the receiver, before even the sender is going to send the data, it's going to actually establish the communication. So to establish the communication, there is something known as three-way handshake, right? So how does this three-way handshake works? Let's say for the first time, before even actually sending the data, it says, hey there, anyone? Right? Are you alive? This PC says, yes, I am alive. Who are you? Right? And this says, I'm the sender. So this is three-way handshake. First of all, it says, hi, receiver. Are you there? Are you alive in the network? This receiver receives the information that's coming from the sender side. This is known as synchronization bit. So that comes as the SYN, right? First. Now, the second one. This is the question and this is the answer. That means, hey, receiver, are you there? And he says, yes, I'm here. I'm alive. Yes. So that yes means it's the acknowledgement. And again, it asks the same question to the sender. Who are you? And that who are you is the SYN, right? Who are you? And this is the SYN. This is the SYN and ACK. And there comes the ACK. I'm the sender. That's the one ACK. So this is three-way handshake. SYN. Hey there, are you alive? SYN. SYN answer is yes, I'm alive. Acknowledgement. But again, with the question, who are you? Right? So for this question, this is the answer. I'm the sender. That's the ACK. So SYN, ACK, and ACK. This is known as three-way handshake. So this communication is actually done for establishment, connection establishment based upon TCP, right? Not UDP. So if the connection is established successfully, After that, the sender is going to send the data, right? So that's how the SYN and ACK works. So again, the ACK, the second, the first one was the SYN, right? And ACK, second, acknowledgement. It confirms the receipt of the transmission and identifies the next expected sequence number. When the system successfully receives a packet, it sends a value, its flag to 1, thus implying that the receiver should pay attention to it. Now, that was simply, I showed you the three-way handshake, right? But what actually happens, let me show you. Again, repeat it. Now, this is the sender, right? And this is the receiver. So on the sender side, when it sends the SYN three-way handshake, right? So the flag, all the flags are there. The urgent bit, right? The urgent bit, the acknowledgement bit, the push bit, so the reset bit, the SYN bit, and the fin bit, the finish bit. All the informations are going towards the receiver. The thing is that everything is 0, 1, 0. So that means where the bit, these are the binary bits, right? So that means zeros are turned off and 1 is turned on. That means when the bit is turned on, that means it's utilizing that specific flag, right? So that is SYN. Now, when it's replying, right? So that would be this and ACK, right? So there would be urgent flag, there would be acknowledgement flag, there would be push flag, there would be reset flag, there would be synchronization flag, and there would be fin flag. So on the other hand, when it actually responds to the sender SYN, it gives you the acknowledgement. Yes, I'm the one. I'm alive. Now, who are you? Turned on, right? So that's the SYN. For that SYN, next answer comes to the receiver with all the flags, right? And the header. So push and reset and SYN and fin, right? So when it comes back to the receiver, it gets everything 0, 1, just except the acknowledgement. So that means this is known as SYN, SYN ACK, and ACK. This is known as three-way handshake, right? And then the three-way handshake actually establishes the connection. After the successful three-way handshake, then the sender is going to send the data, right? Yes. So acknowledgement is doing some kind of act that I have received something that you have sent me. And yes, this is it. And now the third one is the push bit, PSH. Now the push bit, when it is set to 1, it indicates that the sender has raised push operation to the receiver. This implies that the remote system should inform the receiving application about the buffer data coming from the sender. The system raises the push flag at the start and end of the data and set it on the last segment of a file to prevent buffer deadlocks. So what it means is, let's say there is the sender, right? So the sender raises the push operation, right? Sender raises the push operation. Why it raises the push operation? This implies that the remote system, right? The remote system should inform the receiving application, of what application it's been using, right? It's going to actually inform the application that about the buffer data, right? About the stored data coming from the sender. It's the stored data coming from the sender. The system raises the push flag at the start and end of the data transfer and sets it to the last segment of a file to prevent buffer deadlocks. So that means when it is being actually marked, that means it actually says that please process, right? Please push the data to the application, right? please push the data to the application. So what it actually means is, so that means if you are running at the push, right, it sends all buffer data immediately. That means the stored data, it's going to send all the stored data immediately to the application, right? That's the thing that our push does. And if we are talking about the fourth one, that's known as urgent bit, right? Now, this urgent bit or the urgent flag, it instructs the system to process the data contained in packets as soon as possible. So that means now the urgent bit is turned on the packet as soon as possible. It's going to be sent to the system. So priority is given to processing the urgent data first, and all the other data processing is stopped. So let me say, what is the difference between push and urgent then? Now, when push is actually turned on, that means it's actually the sender, the stored data in the buffer. It's going to be actually sent to the receiver, and the receiver is going to apply and send it to the application. That means maybe the data is being flowing, right? So that means if the urgent bit is turned on over here at the last data, that means this is going to be prioritized first, and these two are going to be um, these are going to be sent later before that data. So that means if the data is performing, right, or being transmitted, and there is another data which is being actually prioritized with enabled urgent bit, that means that data is going to be prioritized first. That means it's going to be sent first, right, before the previous data it was actually sent. So this is how the urgent flag or bit works. Now let's talk about the fifth one, which is known as fin bit, also known as finish bit. It is set to 1 to announce that no more transmission will be sent to remote system, and the connection establishes the SYN flag is terminated. Now, what does that mean? Let's say three-way handshake has been established, right? The connection has been established after the three-way handshake. Now, data has been sent through sender to the receiver. That means all the data has been transferred, done. When it's done, that means the sender is going to now send that. If everything is done, that means I'm done, Finbit. I'm done. I'm actually terminating the session from my side. Now this receiver says, okay, that's cool. That's known as ACK. By that fin, this is known as ACK. Acknowledgement is okay, that's cool. Now it comes from the other hand, it gives you the fin. Now I'm terminating from my side as well. Now this sends you the ACK. So this is the four-way handshake. So let me clear and make you understand clearly again. First of all, three-way handshakes, right? SYN, right? And then SYN, ACK, right? And then ACK. So that means SYN is over here, SYN and ACK over there, and then ACK over here. So that means this is three-way handshake. After the three-way handshake is established, the connections gets established successfully, and the data gets transferred, right? Okay, all the data are being transferred, and acknowledgement has been received. Done. That's all. Now, if the data, if the sender says that, okay, no more data left, everything is being transferred to the receiver, right? If everything is transferred to the receiver, now sender says, okay, now Fin, I'm actually terminating the connection from my side. This receiver says, okay, cool. Now this receiver says again, okay, if you're done from your side, then I'm done from my side as well. I'm going to terminate from my side. So the sender says, okay, that's cool then. So this is known as four-way handshake. Either you can state it as four-way handshake or four-way termination, right? So three-way handshake, before even sending the data, it's establishing the connection. Data has been sent. If everything is completed, then four-way handshake. That means now what the connection was established, I'm going to actually tear down that connection. And everything is done, then you're good to go. So this is how the fin binit works to finish or to complete this session. Now, at last, the sixth one, right? Sixth one, it's the reset bit. Now, when there is an error in the current session or current connection, this flag is set to 1 and the connection is aborted in response to the error. And attackers use this flag to scan host and identify open ports as well. So yes, how does it work? Let me show you something. If let's say there is the sender and there is the receiver, right? And sender and receiver is connected to one another, and sender sends the information, right, to port number 80. If the port number is 80 is turned off over here, it actually tries to say that reset. That means I don't understand what you're trying to say, right? Why? Because the port is turned on. Reset, that means reset the connection. Either it could be done in three-way handshake as well. If three-way handshake, right, doesn't establish the connection, maybe this receiver can send to the sender as, okay, I don't understand what kind of communication you're going to do. Please try to reestablish the connection. That is known as reset, right? So if the receiver or sender doesn't actually understands what sender is actually sending or receiver is actually replying, at that point they are going to set the reset bit to reestablish the connection. That's how it works for reset. And for attackers, it's a great tool or great flag to actually scan the host, right? So SYN scanning mainly deals with three flags. So if you are doing the SYN scan, you're dealing with the three flags as SYN-ACK and reset. You can use these three flags for gathering legal information from servers during the enumeration attack, right? So that's how it works. And TCP connection, TCP is the connection oriented protocol, right? So it prioritizes connection establishment before the data transfer between the applicants. This connection between protocols is possible through three-way handshake, as I've already um, showed you, right? The three-way handshake, how does it work? So that's how pretty much it works like. And I also showed you the work of pushbit. Pushbit actually is for the remote host to make sure that the remote host actually is um, sending or sending the stored data to the application. Urgent bit is being prioritized to the data. And then the reset bit actually is used for reset. The fin bit is actually used for the finish, the completion of the connection, right? We use that. So yes, and this is it in this video. Hope it was informative for you. I will see you on my next video. Thank you for watching.